Okay, now let's continue with the data modeling. And so far, we have only worked with one entity, which is our customer entity, and we annotated it with add entity, add ID, and add generated value. And we already have a database table in our H2 database that, as we can see, just uses the class name as table name and uses the exact attribute name as column name for different columns. But we can also do a little fine tuning in this entity still. So to start with, we have the add table annotation. And with the table annotation, we can define a custom name for this class. So we, for example, could use client as a alternative name for this table. And we can also use the add column annotation to change the name of a column. So in this case, I'm going to keep this column as first name, and I'm going to call this one surname. And yeah, let's just restart the server quickly and look at the changes. And as we can see now, our table is called client, and our last name column now is called surname. And yeah, this is something that you will usually do because you don't want to use the exact attribute names every time. Um, for example, if someone goes into your code and wants to refactor the attribute name, this would break your application basically because it would not assign the exact attribute name to the database column anymore. So even though you don't change the name, it's always recommended to, yeah, to just define own column names. So I will undo this. I will actually call this last name again, and this one customer. But there's more stuff we can do. So for example, we cannot only define a name, we can also um, define some database constraints. So for example, we could say that the email must be unique, or we could say that the last name length should not exceed, yeah, let's say 50. And we can also say, now let me just call this, define this name as well. And we can restart our server and just see the changes that we just did. Okay, so reload the database, and we can see that the last name now has a length of 50, and that we also have a new constraint, which is the unique constraint for the email column. So this is some stuff that you can do, that you should do, and you only have to be careful that all the constraints that you put in the database only have an effect if you actually create the database scheme with Hibernate. If you are working on an existing data model already and you're remodeling that in your Java application, then it's also very recommended to add these attributes just to document the code, just to if someone is in the Java world typing his code, he can also have a look into the database constraints without actually looking at the database. It is recommended to do that, but it won't have any effect on the database. Okay, so now we can see that we have some more entities in our model which are not in our database yet. And to um, to continue with the data modeling, we will just have a little look at the entity relation model that we are trying to build. So we already have the customer entity, and we want that our customer belongs to a company that our customer has a driving license and that our customer can rent one or more cars. The car has one car type and the driving license has many car types, and also a lot of car types belong to multiple driving licenses. This is just because maybe with a certain driving license you can only drive cars, and with the other driving license you can also drive trucks. So this is a yeah, this is a the model that we're trying to achieve um, with our model over here. And yeah, let's start with our customer entity. So for the customer, we see that the customer has a relation to the company, to driving license, and to the car. And let's start by modeling our company class because it's very small. We will just add the add entity annotation and the add ID annotation and the add generated value annotation, and that's it. And with that, our company entity is already done. And now we will add the company to our customer. And how can we do that? Now, these attributes that we have seen before are simple attributes that we can just write into a column, like a date, a string, or an ID. Now, with the company as a whole object, we have to define a relation. And in our data model now, one customer can only belong to one company, but obviously a company can have multiple customers. So the annotation that we have to use is called ManyToOne. Yeah, and then we can just generate the getters and setters, or the getter and the setter, and we already have this modeled. And now we can restart our server and see what Hibernate has done. We can reload the scheme, and we can see that we have the company and we have the customer table, and in our customer table we now have a company ID, which is nice. So we already have the relation from the customer to the company just by adding the add ManyToOne annotation. Now the next thing that we want to model is the relation from the customer to the driving license. So again, we have to go to our driving license, and we can just do the exact same thing. We can add the add ID and the add generated value. And in the customer class, we have to declare our driving license. And now, unlike with the company, we will say that one customer can have one driving license, but one driving license also can only belong to one customer. So instead of a many-to-one annotation, we would use the one-to-one annotation. And we will also generate getter and setter. And we could now restart the server, and we would see that this should work. But we are going to just finish the modeling now. And the next thing that we have is the car entity. So we want a customer to be able to rent multiple cars. And just like before, the first thing that we need to do is to do our three magic annotations and then go back to the customer. And we can say private set. Now we are using a set, a collection to actually do that. And we can say set of car, and we can say that this is rented cars. And I'm just going to import the set. And what we are going to need now is the add OneToMany annotation, because one customer can rent many cars, but one car can only be rented by one customer at a time. And again, let us just generate getter and setter. And also now that the car has a car type, so we need to do the exact same thing. By now, I think you can already you already know by memory which annotations we're going to use. And we go to the car entity and we say that this is also a ManyToOne annotation because a car can only have one car type, but one car type can belong to many cars. And last but not least, we will think about the driving license, which says that one driving license can have multiple car types, and one car type can also belong to multiple driving licenses. So we have a many-to-many association. So we can just go here and do a set of car type, and we say valid for car types, and we say add many to many, and that's it. Now, we have done a lot of modeling, and we will restart our server. We reload our database, and we can see that now we have a lot of tables. Now, we can see some tables that we did not define ourselves. Let us first have a little look in the car. So the car has a car type ID now, and the car type is just two values. Company I've already seen. We can see that our customer has the company ID, just like we've seen before, and we have a table here that is customer underscore rented cars. So this is a joint table that represents the one-to-many association between our customer and our car. So this has only those two keys, the customer and the rented car ID. But we can say, okay, this is only a one-to-many association, so we don't actually need a joint table here. So what we can do is we can go to the customer entity and we can say one-to-many, and we can add the add join column annotation, and we can say join column customer ID. And what this basically does is it says in the many um, object, so in car, this will create a column customer ID that will point back to customer. So we can restart the server, and once the server has started, we can reload the database, and we can see that this table now is gone, and instead in the car entity we have a customer ID. So this is I personally like this way a bit more than the join table. It's a preference thing, I think. And we have something else. We have the driving license, and we have the driving license valid for car types table. And this is a many-to-many association, so we actually need this table. But what we can do is we can also define a name for this. So we could just call this, for example, driving license car type, just to make sure that this is just a joint table. We don't need the valid for, and we can just restart the server again. And after that, when we reload the database, we can have a look at our entity relation model and see if we achieved what we were planning to do. So now we have 1, 2, 3, 4, 5, 6, 7, 6 tables, and I'm going to use this little tool. I'm going to show a diagram, and I will check if we have done everything right. And for me, it looks quite the same. Yeah. So as you can see, it also creating um, a little more complex data model where different entities are related with each other is fairly easy with Hibernate. And the next thing that we want to do is we want to see how these entities behave together. So we go back to our customer CRUD controller, and we still know that we have our create method. And I'm going to generate a new request now. I'm going to delete everything else because we changed our data model. And we will create our customer again. And we can see that this time we also have the company, the driver's license, and rented cars. So let's say the company for now is null. Our customer does not have a company, but he does have a driving license. So let's look how the driving license looks. We can say ID is 0 because we want to create a new driving license. We can say driving license expiry date is this date. We can say that the issuing country is Spain and the license number will be LN-1. Now, what will happen if we try to create this entity? Well, what I would expect in the first place is that it will create our customer and it will also create the driving license object on the database. So let us see if this is what actually happens. I will just execute the endpoint and we will see that we got an error back. Why is that? Let us have a little look in the log. Now it says exception, persistent instant reference, and unsaved transient instant of driving license. Okay, I have no idea what that means, or I would have no idea what that means if I read it for the first time, because the actual error what has happened is more likely to be found if we look at the SQL statement that was generated by Hibernate. So we can see that Hibernate tries to insert a customer with some driving license ID. But what we don't see is a statement where the actual driving license will get inserted. And of course, this is a problem because in a relational database, we cannot just create an object with reference to another object if the other object does not exist yet. And to solve this problem, we can do the following. We can go into customer and we can use the cascading type. What is the cascading type? The cascading type is the cascading attribute tells us which operations will get propagated to child entities of this parent entity. In this case, we have a clear parent-child relation between the customer and the driving license because the driving license doesn't make sense without the customer. It belongs to one person only. So what we want to do is we want to say if we work on this person, we also want to update the driving license. And we can do that by setting the cascading type. We could, for example, use the persist type. This would mean that only for the persist operation of the customer, we would also propagate this operation to the driving license object, which would be actually enough for what we just tried to do, because we tried to persist it. But we could also use merge. This would only work for merge operations then. Or we could use remove. And there's also one thing that is all. And we actually want to use all because we really want to propagate all the operations from the customer to the driving license. And when we restart our server and we execute the endpoint again, we will see that now it will actually create a driving license object on the database as well. So now we can just see it has worked. It gave us back our customer with driving license. And if we look into the customer table, we see our customer here. And if we look into the driving license table, we see the driving license here. So this is very important and very important attribute in the data modeling, the cascading type. Okay, now the next thing we are going to do is we will write a method in which we can assign a car to a customer. And for that, we are going to create a new endpoint, which is we are going to call car assignment controller. And we will make a REST controller. And we will do a little method, which will be called public void assign cars to customer, and we will get as arguments a list of long, and this will be the car IDs, and we will get a long, which is the customer ID. And that is all. Now, and this is going to be a request parameter, and this is going to be a path variable. And now we need to annotate this method with add post mapping. Close this over here, and we will call this endpoint assign cars to customer /ID. Oh, I don't remember if I need to use the curly braces or not. Yeah, I need to use the curly braces. And we will also need to do this transactional because it's going to write to the database. And we will need our entity manager, and we need to inject it. Now, what do we want to do in this method? So the first thing that we want to do is we want to find the customer with this ID. And the second thing that we want to do is we want to, well, let me change this actually to, let me change this to one car for now. Path variable, car ID. No, request parameter, request param car ID, long, and we call this assign car to customer. And we need to find a car from the database. And after we found the car, we want to assign this car to our customer. So we want to say customer.get rented cars.add car. Now, we could do it the same way like here. We could also just we could create a customer and we could just write our car inside the customer object and set the cascading type to cascading type all over here. But now we don't really have the same case like with the driving license, because when you can say that the driving license totally depends on the existence of a customer, you cannot say that about a car. A car can exist without the customer, totally fine. And if we want, for example, delete a customer, we don't want to delete the cars. And if we want to update the customer, we don't want to update the cars. So maybe setting the cascading type here, over here, not here, here, we could also do it here, cascade type all, is not the best choice for this data modeling. Now, how can we do it then? Well, the actual thing that we need to do in this case is we need to add the car to the customer and the customer to the car and then persist both. So we need to do entity manager.persist car and entity manager.persist customer. But for now, only the customer knows about the car. The car has no idea of its customer. And we need to change that. And we can change that by also declaring the customer in the car entity. We can say add ManyToOne. And we can say now here add join column. So we define the join column over here and we say name equals customer ID. And we generate the getter and the setter. And we go back to our customer class and we can see that we already have the join column over here. Now we need to change this now because we need to tell Hibernate that it doesn't need to map this thing twice. So we can say mapped by, and then we need to use the attribute name from the car that declares the customer. So we go back to our customer class, we say mapped by customer. Okay, and now we can actually go back to our car assignment controller. We can say customer.getRentedCars at car, and we can say car.setCustomer customer. All right. Okay, so before we continue, let me just fix two errors that I did in this method. On the one hand, we need to call the parameter over here customer ID, so it can be mapped to this path variable. And the second thing is, as we assume that the customer and the car already exist on the database, we want to use the merge method over here and not the persist method. And now to continue, we see that in this method we assume that we already have a customer and already have a car on our database with a certain ID. But we don't really have data for now, except when we create customers with our endpoint. And to fix that, or just to create some test data on the database, I created this data.sql script, which has to be placed into the resources folder of the project. And this SQL script will now always get executed before we start our server, or once our server has started, it will get executed, and it will just create two customers, two car types, 4 cars, and a company to our database. And to make this actually work, we need two new properties in our application properties file, which are spring.sql.init.mode set to always, and the spring.jpa.defer data source initialization to true. The first one, just tells Spring Boot to execute these scripts, or this script in this case, and the second one tells it to execute the script once the scheme has been created by Hibernate. Okay, now we can just start the server again, and we can take a look at the database to see if this actually worked. And we can see that we have four cars on our database, and we have 2 customers over here, and we have 2 car types. So our database is a little bit more filled now with some data, And now we can continue with our method. And for that, we will open the request, generate the request HTTP, and we will just execute the request. And what it will do, it will look for the customer with ID 1 and the car with ID 1, and then it will assign the car to the customer and the customer to the car, and it will merge both with the entity manager. And we should expect that this would work, and that now and then on the database we can see that the car actually got assigned to our customer. So let's try this out. And yeah, it seems to be successful, and we can now take a look in the car, and we can actually see that our car number 1 has been assigned to the customer with ID number 1. Okay, so this would be the way that we can manage a relation, a one-to-many relation between two independent entities where we don't want to use the cascading type. And while this mapping is very correct now, I think we have done a very correct mapping, because we don't want to update the car when we update the customer. We don't want to remove a car when we remove a customer. So really cascading type is not the way we want to do this. This also comes with a big downside, because the bidirectional relation between these two entities has to be treated very carefully. We really don't want to forget, for example, like we could, for example, forget to add the car to the customer. And sometimes it's not even a problem at the first place. You won't notice any difference maybe. But if we don't do it, there can, like, data inconsistencies can occur that can even lead to data loss. So a bidirectional relation has to be managed very carefully. I just want you to keep that in mind, that when you don't use the cascading and use a bidirectional relation instead, or you can even use a bidirectional relation with cascading as well, you really have to be careful and always assure that you manage your data correctly. Okay, so we have seen the cascading attribute, we have seen the map by attribute, which we can use for bidirectional relations. And if we take a look into the relation, we can see that there are two more attributes that we want to take a look at, and these are the fetch and the orphan removal. And let's start with the orphan removal now. And for that we can have a look at a new customer that we're going to create. And when we create this customer, we have already seen that as we're using the cascading, this will also create a driving license. Now, what would happen if we delete this customer? What would happen to the driving license? Well, as we used the cascading type all, the remove operation will get propagated to the driving license, and the driving license will get removed as well. So we can just try this out. We can see that our customer has been created with the ID 3. So we will execute a delete endpoint or request with the ID 3. And now we can see that our customer has been deleted, and our driving license has been deleted as well, just like we expected. Now, what happens if we create this customer again? Oops. If we create this customer again, and now we will call the update on this customer. So we need to update the customer with the ID 4. But we will set the driving license to null. Let us just see what happens. So the customer is still there because he only got updated. and he doesn't have a driving license ID anymore, but the driving license object is still on the database. And there are certain cases when we don't want that. And I think this is one of these cases, because if the customer loses his relation to the driving license object, there's actually no point in having this driving license object on our database anymore, because this driving license only belongs to a certain customer. And if the relation got broken, basically that means that the driving license is now a orphan. Yeah, it has no relation on this database anymore. It has no purpose to be on this database anymore. And this is where we can use the orphan removal. We can set it to true, and we can have to restart the server. And now if we execute an update on a customer that has a driving license and we set the relation to the driving license to null, this will remove the driving license from the database as well. So we can go to our request, we can create a customer with a driving license so that the customer has ID 3, and now we will remove, or we will update the customer, but with driving license set to null in this case. And now we can see that the customer is still there. He has no relation to the driving license, and the driving license is now gone. This is what the orphan removal attribute does. Okay, now to see the last important attribute of the relation annotations, we want to see the fetch attribute. And to see the fetch attribute, we are going to go back to our customer CRUD controller, and we are going to modify our read endpoint a little bit. We won't let it return a value now. It will just read the entity from our database, and we'll restart the server. And we will open the generated request HTTP. And now what we're going to do is we are going to create a customer first with a driving license. And now we will assign a car, the car with the ID 1 to the customer with the ID 3. So now our customer with the ID 3 has a car and a driving license. And now we are going to execute our read method for the customer with ID 3. And now now we have to go to the log and see what Hibernate actually did. So this is where we executed our read, and we see that Hibernate selected the attributes of the customer, joining to his company, and also joining to his driving license. What we don't see over here is the car. So there's no car. There are no car attributes in this select statement. But if we look into the car table, we can definitely see that our car got assigned to the customer. And this is because of the way Hibernate fetches the entities. If we go back to the customer and we go to the one-to-one association of the driving license, because we can see that the driving license is over here, or the ManyToOne association of the company, we can see that the default fetch type is set to eager in the ManyToOne and also in the one-to-one. But in the OneToMany association, we can see that the fetch type is defaulting to lazy. Well, what does that mean? It means that when we fetch our customer from our database, Hibernate will directly load the company and the driving license object as well, but it will not load the cars. So to demonstrate the behavior of the lazy loading, what we can do is we can save the customer. We just get back here into a variable, and then we can access the cars, and we can do a simple operation on this car, and we will just no, I don't need this. We will just print the brand of the car, and I will actually set a breakpoint over here. No, I will set it over here and over here, and I will just start the server in debugging mode. Okay, and the first thing we're going to do is we're going to create our customer. We're going to assign a car to our customer. Then, just to make this more readable, I'm going to clear the console, and now we will read our customer. So we just came to hold over here. We can see that nothing happened in the console yet. If we go one step further, we can see that now it loaded the customer, and it only executed the SQL script where it selected customer, company, and driving license. And now, when we actually do stuff with the cars, we will see that the next select statement appears, where we select the car, and at the end it prints the brand of the car. So this is basically how lazy loading works. And the purpose of lazy loading is improvement of performance, because when we only load stuff from the database when we actually need it, especially when it comes to collections, we can save a lot of database operations and a lot of database traffic. On the other hand, there's also some stuff with the lazy loading that you need to be careful about, because Hibernate loads the data when Hibernate thinks that the data should be loaded. You cannot always rely that this is the time that you also want the data to get loaded. So it is really nice feature, lazy loading, to improve performance, but on the other hand, you also have to be careful with it. You can set, if you really want to be sure that when you load the customer, you also have the cars right now, then you have to set the fetch type to eager. And by setting the fetch type to eager, we can just restart the application again. By setting the fetch type to eager, you can always assure that Hibernate will load the whole collection, and actually the whole collection when you load the customer. So we can just do the same thing like before. We create a customer, assign a car, and do the get, clear the console. Where's my, oh, yep. And we can go one step further. And now we see that Hibernate did the select from customer, company, and car, and also car type. So we can see that this select statement got way bigger than before, which will lead on a big database with a lot of data. It will lead to performance issues. I can I can almost assure you that, but sometimes you also need to be careful with that. And again, just like with the cascading, it's a design choice. If you want the eager loading or the lazy loading, if you want to use the eager loading or the lazy loading, and yeah, it depends on your application at the end. Okay, so I will just let the debugger run through, and I think that's it for our data modeling video. We have seen a lot of stuff. We have used the table annotations. We have used the column annotations to set a table and column names. We have seen we can set constraints in our columns. We have seen the one-to-one, many-to-one, one-to-many, and also many-to-many association. And we have also seen the most important attributes of these associations. We have seen what the cascading type does, what the orphan removal does. We have seen why we have to use mapped by sometimes in a bidirectional relation. And we have also seen what FetchType does to our data model and the way Hibernate fetches the data. We have seen, and this is the last thing for this video, that I really want to make an emphasis, that we have to put a lot of thinking in our data model. And if we do it at the beginning and if we do it correct, we can really have a nice application and a nice data model. But if we just model without care, if we mix up the fetch types, if we don't care if we use a bidirectional relation or unidirectional, when we use cascading, this can end up in a huge mess. So whenever you're modeling your data model, be careful, invest a lot of time in thinking before actually modeling it, and then you will have an amazing data model with Hibernate. Okay, I really hope this video has helped you and will help you in the future. I would really appreciate a like, and I would also appreciate every comment, either if you have a question or a suggestion for this video. Please just write everything in the comments. I will try to answer as many as possible. And thank you so much for watching. See you next time.